All right, so we're gonna go over my little reflective discussion for game programming. We're gonna show off, I guess, talk about what I did, why I did stuff that way, and we're gonna show some other stuff as we go. So I'll start with just, I guess, showing off some stuff in our quick test scene that we have. Make it a little bigger so it's easier to see. But, load in, move around. I guess first one was didn't really rework it, but we added the two icons to the numbers just to make it a little simpler to tell what you had. We will likely have to rework it again after our playtest to see, 'cause it still might not be perfect, but it is what it is. But with the ores, so first, one of the things I'd done this sprint was create like a quick shutter effect, which just moved the ore around basically. So it kind of shakes a little. When it's hit, it's not a very obvious shake, but it is there. We get the damage numbers that pop up. As you just seen, this red ore switched to a new state, which is our it's called degradation states. I might be saying that wrong, but yeah, these do respawn. It just takes. We have it set really high right now. Yep, there it goes. It respawns back as another one of the prefabs, and it's a little hard to tell here as I only have the one controller plugged in right now. But if we were to add a second player, uh, each character model is tied specifically to that player index. So the first player that joins in will always be green. The second player will always be purple, and then I believe it's blue and then orange, just to make it simpler for now. We may rework that so that you can choose which one of the characters you want to be, but for now, that's not really a priority for us. So I will back out here, and so I guess the shake is fairly simple. I just take, duration, the magnitude for it, and damping speed for it. We take its initial position and store it, you know, and just as a quick, I guess, more of a safety test, we just make sure, if the object gets destroyed, like mid-shake, like when it goes to its depleted state, we just make sure it goes right back to where it's supposed to. We have our start shake method, which basically just starts the coroutine, which, so we test to make sure that it's, you know, see whether it's going or not. If it is already shaking, restart it just so it's not, just so it doesn't wait and then go after that. And then, yeah, we take the random horizontal offset, make sure it moves relatively smoothly, and then have it return to its original position. I figured I had the option to go between either having the screen shake or having the ore move, having the ore kind of shake or shudder. And I figured this would be a simpler solution to do it, as well, I guess either one would have been easy, or not necessarily easy, but not super hard. I just, since every player is using their own canvas instead of one canvas, I figured it might be simpler for me to figure this out first so that it's not just shaking the whole screen. And it made a bit more sense, to me at least, to have the ore shake instead of the screen shake, since it's not the player that's moving, it's the ore. But one of the next tasks was, this is just a little damage pop-up that I pretty much took from a different project I'd worked on and brought it over here for test it, to use. But we serialize a bunch of fields, like the lifetime, how long it stays in the scene, its float speed, a random radius, which didn't quite work the way I wanted it to, as it just kind of pops up us in the same spot. So I think it's fine the way it is. But yeah, we take, get get a text component, and then take the damage from the player component, and you use it as our text, which is always 10. You know, set its color, set the alpha, and all of that, and then we have it be randomly offset around the OR. And basically, when it hits or when it plays, it just kind of floats upwards a slight bit and then fades out. And after a set amount of time, we destroy the game objects just so there's not multiple in the scene, because we didn't want to we want to have to deal with having 20 plus of them just lingering in the scene and affecting the game, slowing it down. Our results screen. This was when I was talking about tying each of the character models to the character. So yeah, like I would take the player index, so that index 0 is player 1, index 1 is player 2, and so on. And that's how so with our results screen, when the game ends, the panels, which I'll pull up real quick. So these panels will move around. So if player 3, if the blue player came first, their panels will be over here under the first place section. And, the orange player was second, they'd be over here, and so on. And that's why I have them set up as anchors. Yeah, I have an empty object anchor under each of these positions. And then I store each of these panels and map them to the player index. So as the green player will always be player 1, they are index 0, index 1, 2, and 3. I also use their, which is the sheet, their panel root, which basically just has all of their information on it. It has the two little banners, their score section and their info section, which are also just under an empty, just to make it easier to move them around. And then we have the text file for the score, which is also within this score sheet. And yeah, it keeps them all in one place and moves them around as it needs to. But let's see if I can find the best place to show it off. Yeah, it's kind of the basics of how that one works. It takes the player index, ties it to which one it is, and drags it along. So we technically refactored how the OR script would work as we added the degradation states to this. And I need to go down to it. But yeah, I used meshes for it. So I had two options with the ORs. If I go down to them, I could have either used a game, just kept them all as separate game objects, and as you destroyed this first state, have it destroy this object and switch to the other state, which would have been way too much work and way too much happening in the game. So we simplified, after talking with another programmer, we simplified it to just using the meshes. So instead of, destroying a game object and spawning a new one in every time you pass that 20 health threshold, we now take the mesh filter and, we check and make sure it's there, check and make sure the state meshes are filled up and aren't 0. If they are, we keep going. We tie our steps crossed method to the get steps crossed total. We clamp this method here just to make sure that, if there are fewer meshes than steps, you stay on the last mesh, which shouldn't ever happen. It's mostly as just like a safety, just in case. And then, we put that state index to the new index and filter it through the mesh, which will be a little easier to go over to the OR. I know I'm explaining this kind of poorly, but it's a little easier if I can drag this out and show it. But yeah, basically we have our state visuals here, which has our state meshes as our list. at element 1 of 0. So it starts with the main mesh and ties for health. So the red ore has 40 health, and you get a reward every 20 steps. So after you bring the ore down to 20, it'll switch from the ore 1 red hit 0 to ore 1 red hit 1 mesh, which changes it to the more depleted state. And then once you go to 0, it then goes and does the depleted state like we had set up before. And yeah, overall, we figured it was instead of constantly, destroying and respawning an object, we figured it would be much simpler just to switch the meshes out. And yeah, there is a bit more that I've done throughout this sprint, which is a lot of it has just been like bug fixing and, getting stuff to work properly. But for the most part, that is my kind of reflection of, what I've done, where we went with it, why it was done, a specific way. And yeah,